As you can see, we had just a small technical problem, as usual. So there is quite a lot of people. I will actually need to pretend that I know what I'm speaking about. So today's topic is Kubernetes, and more specifically, operators in Kubernetes. How do they work? What they are? What are custom resource definitions? How potentially we can use them. So if you don't know what Kubernetes is and what problem does it solve, essentially, just to simplify it, Kubernetes is a container orchestrator. What does a container orchestrator means? So container orchestrators are essentially managing containers. They provide also clusterization for those containers, so we can create large clusters with many nodes to which we can host our containers, and the orchestrators are essentially managing the state of our containers and our applications. Furthermore, Kubernetes is providing quite a lot of extendability, and that is a very important point. Because in Kubernetes, we can extend it however we want. We don't have something which is provided natively, then we can extend it. So we can pretty much tailor it to our own use case. And that is very powerful tool. Also, we have another actually important point, which is the community. And I do not mean by community just asking in Stack Overflow, okay, how can I do this? Or just finding something for Kubernetes in the internet, let's say in GitHub. Community actually means a lot for Kubernetes because Kubernetes is community-driven. That means that essentially to develop Kubernetes, you need to have a big community which is taking part of it. And as of now, as far as I'm aware, if you want to find a solution to deploy on container orchestrator, it is far more likely to find it, for example, in Kubernetes than any other orchestrator, for example, in HashiCorp Nomad. It's just more popular. So Kubernetes actually, I'm not thinking that it solves every unique case, but yeah. So how do we deploy usually in Kubernetes? First, we need a cluster. So how we would create our cluster? Usually, we would use a tool like, let's say, like Terraform. Terraform will build our cluster, will create it essentially, let's say in a cloud environment in Azure or AWS, and we will have our own cluster. Then we need our application, which will build and test on containers, for example, Docker, and we will publish most likely our containers to a remote registry. So we have our cluster and we have our containerized application. Then what we do? We deploy it, but how do we deploy it? And here it comes the tricky part. We will usually write quite a lot of Kubernetes manifests. And what are Kubernetes manifests? Kubernetes manifests are one quite big, I would say, either YAML or JSON files. And they are quite a lot because we usually separate them. So we have one for our deployment, one for our, let's say, database secrets. Also, we have for our app settings file, we have a config map, and we also have probably a bunch of volumes. And if you deploy a microservices-based application, you'll have a lot of those. So we deployed, let's say, using this example, our application with a lot of Kubernetes manifests. Then, what challenges would we face? Well, we'll have several challenges. One is not being able to scale dynamically according to the state of our application. We can most likely still scale on CPU and memory-based metrics, but we all know that they are not 100% correct what our application is doing. So to tackle this issue, we need to scale our application by using the state of it. So what is our application actually doing at the moment? Let's say that it's processing something and the intention is to have a lot of CPU and memory. Also, we face another challenge. We have no in-cluster automation. So let's say that we have these big deployment pipelines, we have the build process automated, everything is automated, but when it comes to the deployed application, it is very much manual. We just depend that we don't touch it, don't touch the production, don't touch anything, it works. Well, yeah, but that can be actually bad because let's say that our applications needs to scale, and what do? We go and scale it manually? Well, that's not really good option. Also, there is no integration between the hardware/infrastructure and the software. Well, in the 1960s, when the National Space Agency of the US, NASA for short, was developing the Apollo missions to the moon, they actually managed to do it with technologies which are so far back. And how they did manage to actually send astronauts to the moon, and nowadays we still have not sent. And we are complaining, okay, my code needs actually 25 CPUs and 80 gigabytes of RAM just for a small web application. Let's not mention the npm install command here. The thing here is that we had quite a big integration between the hardware and the software. Or in a sense, our infrastructure knew what code it was running, and our code knew on what infrastructure it was working on. So there was very big automation part and integration. For I would say the last 10 years, especially with containers and so on, it was like kind of the perception coming that we build it once, deploy it everywhere, or it should work on any infrastructure. It's called infrastructure agnostic, so our application should work everywhere. Okay, but that's not really the case, or I would not say. This is quite a lot misunderstood, because we still would need to have some integration with our infrastructure if you want to have bigger optimization. And the last point would be the cloud part is missing. Well, essentially we have Kubernetes, we deploy something, but where is the cloud part? Okay, our cluster might be on the cloud, but are we using anything apart from just, let's say, Microsoft managing our cloud-based Kubernetes? Most likely not. We might have some managed database which we deployed alongside manually or any other code, but in the big part, our cluster it's just staying as it is on on-prem, and we just deploy our manifests. Okay, so how we can potentially solve those challenges? Nobody knows Kubernetes. Where does this came from? Well, it comes from this acronym CRD. CRD stands for Custom Resource Definitions. And as it is in the name, there are something custom in Kubernetes. And nobody knows it because everybody can write their own custom resource definitions. And if you can write your own, you cannot know what some guy, for example, in the UK decided to write as a code, and you say, yeah, I know Kubernetes. Yes, but you cannot know everything for sure. So CRDs. CRDs are custom Kubernetes manifests, as everything it is. So we deployed via custom Kubernetes manifests, which we write. I'm going to show an example just later on. And it is just a record inside Kubernetes. So it does not perform any action by itself. So it is just a record inside our, let's say, SQL database. We can imagine it like this. This is very simplistic explanation. We can also have one really good option, which is multiple versions. So we can have multiple versions of this CRD and what kind of parameters accept. So let's say that we introduced a new feature, we can introduce it to the new version and mark the old one as deprecated, and the new version will have more properties essentially. And finally, it is Kubernetes object like everything else. So we can work with it with the API like we work with pods, deployments, config maps, and everything else. So if it is just a record, how would we actually use it in Kubernetes? It's just a record, it's nothing. It stays written, but that's it. And here it comes the Kubernetes operators. So the operators are what it actually takes action. So it can monitor for those custom resource definition and deploy something based on them. But operators are a little bit more. They don't operate only on the basis of custom resource definition. In the most essential form, there are some piece of containerized code. So that can be Python, Node.js, Go, whatever you want. they also interact with the Kubernetes REST API. So they are essentially connected with the cluster by connecting to its own API. And very important point here, they can interact not only with the Kubernetes API, but any other API in the world. Let's say that we have some food delivery app. It can also interact with that food delivery app alongside with the Kubernetes REST API. So it can interact with both and do something with both APIs altogether. And the final point is that they constantly need to monitor our application and cluster. And why does it need to monitor those things? Well, it's essentially should be able to see what is going on, what is happening, and take actions based on what it sees. So some example operators you may find for AWS and Azure. They have multiple ones, for example, for ingress controllers, for deploying some databases, and so on. Prometheus have very popular operator, which is for deployment of the Prometheus and Grafana stack. And you just type 3 commands, everything is deployed. You have your monitoring, you have your graphs, you have your alerts, and that is done just by 3 commands. And the thing here is that the Prometheus operators are actually doing all this. We can also have, for example, some operators for managed databases and so on. And the source for this is in one very cool website called operatorhub.io, and you can find quite a lot of operators for pretty much anything you can think of there or anything it is written. So I'm gonna step to the first demo, which is actually creating dynamic worker processes. And what I mean by this, let's say in this example, we have, let's say, one simple queuing service, which accepts messages. And we need workers to, let's say, process those messages. How we can integrate this with Kubernetes? So if we go to the, just let me move my screen, okay. So I prepared the demo. The first part here is our deployment. Because operator needs to be deployed as usual, we cannot avoid the manifests. So I'm gonna skip to the deployment part. So we just have a simple container. We deploy it with service account so it can interact with our API. And we have also attached some secrets. So it can interact, in my case, with the AWS API. And we also have some code. And that code is actually very simple. So I'm written this quite quickly in Python, and we have 2 main packages. One is the Kubernetes package for Python, which is a wrapper for the API, and we have another package which is called Bot3 for interacting with the simple queuing service in Amazon. So it's a quite simple code where it just follows the queue, so interacts with the Cloud API, and it creates me worker processes based on the how big our queue is. So if we go right now to the demo 1 folder, maybe we can try to apply it. So we are gonna apply the operator, and let's see if it would be applied. So we did not mention something. Okay, and we deployed our operator. Okay, let me open some very cool program, which is called Lens. It's just a Kubernetes ID to be able to show it. And as of now, you can see our operator is deployed, and we have 1 worker process. And what is this worker process? Let's go back to our queue. And I also have a simple script. Just let me expand maybe this. So a simple script which will create some messages. So I've created some messages really quickly. Let me scroll. And yeah, messages and some random string. And if we go back now, we can see that our operator is spawning workers which are processing those messages. And when they are succeeded, essentially they're queued and they die. So we can spawn dynamically containers based on the state of our queue, which is also in the cloud, so we interact with it. So let's gonna queue our operator here, because we don't need it anymore. Okay, and let's go back to our presentation. So the next point would be demo number 2, and this is defining our application as a custom resource. So let's say that we are a SaaS company which provides some kind of a SaaS services, and we need to deploy an instance for each of our customers. But if you worked in such a company, you know that every customer comes and they have their own requirement, and you need to configure it per their own requirements, and it becomes a mess. So let's say that this customer wants Postgres SQL database, another wants MySQL, another wants MS SQL, and congratulations, you have quite a lot of problems. How we can solve this potentially in Kubernetes? So let's go to the demo number 2, which is custom resource definitions, and we have a little bit more files here we can look. So the first part is our custom resource definition. And we can see that this is actually quite straightforward, very simple object for Kubernetes. So we define custom resource definition as a type, and then we pass some properties. I've defined only one version, which is version 1. And then we passed 2 custom properties, which I called image. And image, it will require to pass it as to pass some string to it. So I'll need to pass some string for an image. And I will also need to pass another point, which is called nodes, or at least I called it nodes, and this needs to be an integer. So in my definition, I need to pass one string, which would be for image, and one option, which is for the number of nodes. So this also needs to be scripted, of course, in your operator to be able to handle these resources. And we have also another deployment file, which is for actually deployment of our custom application. And you can see here that I have image and I have number of nodes. In our case, one would be with 2 nodes and another would be with 3 nodes. So if you go back and actually deploy our thing. So first, let's say we want to deploy our custom resource definition. So I've named it my app, CRD. So if we click apply, we've created it. Now we can create our applications. Okay, let's deploy 2 of our applications. Okay, we've created them. And if we go again, we should be able to see our custom resources, which are deployed just 10 seconds ago. And we have 2. One is MyIsta and another one called Very Cool App. But we cannot actually see any pods or anything being created. That's because, as I told you, this is just a record. So we need to deploy actually an operator which manages those custom resources. So deploy it. That means it's created. And we have our operator, which is currently starting. It's probably pulling the image. So if we give it a second, or maybe just check on the status. Yeah, it pretty much started, and immediately it created our application, which we have 2 nodes of the Very Cool App and 3 nodes of the application, which is called MyIsta. So let's go back to the presentation. And let me just expand it. So what we were able to demonstrate in these 2 demos. So we were able to interact with the cloud service provider API. In our case, we just followed an SQS service, which is in Amazon. And we actually changed something in Kubernetes based on the external state. So we interacted with both different APIs to change something on our application. So to summarize, we interacted with another software to change our infrastructure state. We have also interacted with the cloud provider SDK or API to deploy resources as we need them. And we also have bundled our application into a single resource. And our operator should ideally know how to manage this single resource or instance of our application in such behavior that it knows that we can have multiple ones. It means that we can deploy different instances for different customers with completely different options, and it should know what is going on. So thank you very much. That was from me, for my demo and my presentation. Some useful links would be the Kubernetes documentation, GitHub page of the Kubernetes client, also some documentation in the Red Hat website, and some other documentation as well. Thank you very much. If there are any questions. Well, we have one question. Just a moment.
Може ли микрофончето? Микрофонче?
So I repeat just when I learn and use Kubernetes, have an impression that Kubernetes operations a bit on the side is not mainstream of the Kubernetes stuff. Yeah? I also see that the big GE providers like WebSphere, Logic tries to wrap somehow web server using operators in Kubernetes. Could you elaborate a bit what is the use cases for operators? When we should keep replica set in deployment, so just a standard way, and thinking about using operators in which cases?
Yeah, so actually deployment replica set is something I would say a bit different than operators, because deployment replica set, they are just Kubernetes objects which deploy essentially at the end pod. Deployment deploys a replica set and so on. But those things, they do not have, I would say, code logic in them. There is, but it is already built in Kubernetes. So we cannot, it's hard to extend this without operator and so on. And what operators are doing, they're essentially, I would say, something like a plugin for Kubernetes. We can imagine it this way. So we need a function which is not already in Kubernetes. We cannot find it in any other platform. And let's say we have a customized application and we want to pass multiple properties. You're probably not going to find it anywhere, so you need to build it yourself. And the way to do this, at least in Kubernetes, one way, it's operator. I would agree that they're a little bit on the side, not that many people in the world are talking about, because you also need to spend development time to develop this operator, to be customized per your own needs, and that is actually quite hard. But in a lot of cases, if you're, for example, a SaaS provider, that can help you a lot.
But do you have some practical examples from some use cases when I see some monitoring systems, perhaps as a good for operators? Yeah. Would you show some other examples?
Yeah, for example, MariaDB or MySQL. If you deploy with something with the operator, usually if you deploy it like a pod, it would be just a single instance. If you deploy it clusterized, you need to manage it essentially yourself and write some logic to monitor is the cluster intact and so on. That is already built into those operators, so they will manage the state of that cluster inside Kubernetes. Of course, it might have some limitations, but it's up to you to customize it. Also, we had a customer which reached out to my company a few months ago, and they were exactly a SaaS provider. They had something which was built, and they wanted it to be migrated to Azure Cloud, also to have an Azure instances. But there was many problems exactly because they didn't use Kubernetes and operator specifically. And they were using exactly very similar infrastructure to what I showed. They were doing some kind of a CRM where they had a lot of components which was spread into multiple services, and they didn't have a central point of actually management.
Okay, thanks.